figuring out, people already saw this. So if I go too fast on the demos and you want me to slow down, I do have access to the pause button and I can move things around. So
I'm getting multiple responses from viewers that we can see. So we're good. We're back.
But what about, did they see this presentation?
Viewer 21 has not seen it.
Okay. So I did modify a little bit so it wouldn't be exact same thing that I did at NI Week. So my name is Fabiola De la Cueva. You can call me Fab, as in fabulous and modest. Emphasis on the modest part. I keep using that joke because it works. People remember my name that way, so I'll keep doing it. I'm a software architect and a partner at Delacor. And there's a link to the videos, including the video of the presentation that I did at NI Week. It's there on the Bitly. And of course, I had to put the picture that we won. The Dqmh won an award for Product of the Year, one of the LabVIEW Tools Network awards. So we're a little proud about that. Our leadership team is Chris in Europe and Luis and I here in the US. I mean, not in Europe anymore because he's in the UK. So my dreams about taking over the European market have shattered. So services, we do software architectural design and implementation, automated test strategy and process optimization, best practices training, hardware design, test station management. The main focus we do is we are consultants. So if there's a group of LabVIEW developers that realize that they're not just drawing, that they're actually doing software development, and they don't even know where to start. We help them to figure out processes, the style guidelines, set up their VI analyzer tests, set up their source code control, and train them on how to do that. So I've been also called by some of my customers the marriage counselor, because I go into companies that might have already a team of experienced LabVIEW developers, but one of them is all about functional global variables, and the other one is all about globals, and then the third one wants to do active framework. And now they are the tech leads, and you have a group beneath them that you now need to figure out how can you compromise among all those views and get something that works for the entire team.
Right, because you can't let them split up. It's bad for the kids.
Yeah, exactly. So I assume everybody here knows how to use VI Package Manager? Yes? All right. I'm not going to bore you with the video at NI Week. I did do a video, so you can find it. Just Google Dqmh and you'll find it, or search for Dqmh in VI Package Manager. Once you install it, you're going to get, the little super CLA guy is not included on the package, but you're going to get that Create Project. So who has seen the Create Project window? All right. Back there, you've never seen the Create Project window? Okay, good.
It's not the new one, it's further down.
Yeah, so once you install the Dqmh, you should see that project template added. So what is Dqmh? Stands for Delacor Queued Message Handler. That I did just make sure that you guys are still awake. The thing that we set out to do was something that would be accessible to NI support, accessible to CLDs, but that CLADs could also contribute to a project. We wanted something that would work with Teston out of the box. It uses object-oriented programming, but does not require to understand it. And it supports multiple instances. And finally, we added my favorite part of the Dqmh is the scripting tools, because they reduce anxiety regarding the creation and the use of user events. We use the Dqmh, so why is it free? It's our calling card. I cannot show you due to NDAs. I cannot show you the things that we've done for customers. So in order for me, when a new customer calls and says, hey, what can you do to make us more efficient? I can say, go check the Dqmh. I'm not saying I'm going to force you or ask you to use the Dqmh. That's just an example of some of the tools that we can do to make your life easier. And did I mention that we won an award?
Hey, Fab, is it true that you won an award?
What was that?
Is it true that you won an award?
Yeah, we won an award. So Dqmh review. I did a 2-minute video that you can watch me suffer through that at NI Week. I figured that this crowd, everybody knows Dqmh. Yeah, I remove all the labels, all the code needed labels.
All copies.
Yeah, just wanted to make sure. So everybody knows this. I don't have to spend time explaining it. Everybody at home, we're good? wanted an image that would relate that I'm going to be doing this in layers. The first layer is the high-level description. It's what happens, what is it that we're trying to accomplish. I'm going to use bubbles, arrows, things like that. Then the second layer is watching the end-user experience. What is it that you see from the front panel? And then the third layer is the actual tour through the code. So this video I made at NI Week. And what I did is I sped out, made faster the video. So when you see a bubble, that means that we're remembering that video, and that's going to go super fast. So if you want me to slow down or go back, just let me know. The main concept that I wanted to cover was that we are managing two types of events, the request events and the broadcast events. We figure out if that concept is not clear, then Dqmh doesn't make sense. So we wanted to make sure that before I take you to look at code, that was clear. Everybody ready? Okay. So now let's see if this wants to cooperate with me. All right. So here comes my first bubble, Dqmh introduction. So how do you create a project? You create a project, you say, okay, create the project, that's the project structure, you get the documentation, you get tree. The application is set at the same machine, it says it starts a singleton, the clonable starts the clonable. Each time you start a clonable, you start a new instance. So the difference is the application is one, then my clonable is clonable. Dqmh request, so let me go back on that one. That was fast, right? Okay. A little bit. Okay, so the main thing here is the application is implemented as a single state machine, the singleton is implemented as a Dqmh singleton, and the clonable is implemented as a clonable. The main difference between these guys is that every time I say start module for the singleton, I will always get the same instance, and every time I say start module for the clonable, I get a new instance of the clonable. Are you good with that? Okay, so now for the Dqmh event, I'm going to show if the application is going to be telling the singleton to do something. The singleton is going to say, okay, I'm doing something, and then it's going to send a broadcast saying, I did something. And then we're going to do the same thing for the clonable. So ready? Here we go. So that's the Dqmh events. Request events are red, then the broadcast events. So the problem with that video, and the reason I when it goes that fast, is that it makes it look like the Dqmh events are synchronous, and that the Dqmh events are one-to-one. And that's not true. That's not true. The Dqmh events are asynchronous. There's a synchronous option, and there are many-to-many. And that's my favorite thing. So I'm going to introduce the test API. So you have a test API for the singleton and a test API tester for the clonable. So the application sends the request Dqmh event, but also the API tester can send a request event. Then my singleton is going to process the one by the app, and then it's going to process the one sent by the tester. Same thing with the API tester for the clonable. The application can tell the clonable one do something, but so does the API tester. And the clonable is going to process the request by the application, followed by the process by the tester. So Dqmh request events are many-to-one. Any VI to Dqmh. This is why request events are public VIs. The broadcast event is both the singleton and the myclonable can broadcast that something happened, and they are one-to-many. Dqmh to any VI register to listen to them. So this is why broadcast events are wrapped by private VIs. We only want the Dqmh itself notifying the world that something happened. Does that make sense? So that's why we decided to use this nomenclature. We based our architecture from a concept that Justin Gors presented at the CLA Summit and NI Week of 2011, and he called it private and public events. What was confusing about that time was the private events were wrapped by public VIs, and the public events were wrapped by private VIs. And any time I would get back and work on a code, I had to kind of like reacquaint myself. So we figured out that the broadcast and the request made it easier to describe what's happening. Any questions about that? Has anybody got an aha moment that was not clear before or not? Probably this audience.
So a request event is to the Dqmh object, and then a Dqmh object will broadcast its results.
Its results, yeah.
Okay.
But
So I feel like I've seen some useful cases for broadcasting to many different modules, but do you have an example?
so I was discussing this with the team. What would be the number one example? A timekeeper, a metronome, for example. So if you have multiple tasks, multiple windows have to work at the same time, and you need something that says, hey guys, we changed from phase 1 to phase 2, and then the rest of the time is just keeping track of time, that would be a module that you want to be able to get from anyone. So a start module and get the same instance. You want to be able from anywhere to say, hey, what time is it, or what phase am I in, right? And then you want that guy also to say, guys, time over, or guys, new time task is started. And then each one of the modules knows how to start. Any other questions? Okay. So, bubble again. So in LabVIEW, what happens? The application says to start the singleton starts. We start the clonable. We get a different window for each instance of the clonable. We have a registry of them. Then if I want to say do something, it did something. If I click the do something, it does something. It goes back with the broadcast. Okay, questions about that? So all of that code gets programmatically generated for you when you create a new Dqmh project. All right, so now I'm going to go a little bit slower. I'm launching the application name. I'm having it on the right, and then my tester on the left. All right? So what I'm going to do is I'm starting the tester first and then starting the application, but it doesn't really matter which order I start them. And then my pinkish window there is my singleton. So what we're going to do is I'm going to click do something. So the Dqmh does something. Then the tester says, okay, my singleton, do something. You can see on the status of the my singleton that it did something and that the last thing that was processed was the message from the tester. And on the tester, you can see that first we received that the button was pressed on the top level application, followed by the tester then saying do something. And on the application itself, even though it doesn't really have any knowledge of the tester, because we broadcast the status, the application itself knows that it did something. So this is the broadcast where we got the message going both ways. Questions there?
So if the human's broadcasting out and everyone's listening for it, is there any way to identify, like, this is the message, this is the response to what I sent, or is this the response?
Well, so the way you see it is in the image on the tester. See how you have the two, number 4 and number 5? So number 4 says my singleton module, so that's the issuer, said that something button was pressed in the top level application. So I know that's coming from the top level application. And then the next message says my singleton module tester was the one that actually sent to do something. Now in this particular case was because we are adding that as part of the payload of the event. The other way you can know statically is that you do a search for the public API that obtains the request, the broadcast, and you figure out who is registered to listen to messages. Right? Make sense?
Yeah.
All right. So if I show you in code, hopefully that will clarify a little bit more. Well, let's see. So from the application main, if I go to the block diagram, you're going to see that it's implemented as a state machine, as I said earlier. The reason we use the state machine is just to show that you can have anything called a Dqmh. It doesn't have to be a Dqmh. It could be a simple series of VIs. It could be producer-consumer. It doesn't matter. The main state we're going to be working on is the wait event. So what I'm going to do is look at start the singleton module. When we do that VI there that was created automatically by the template is the one that says start. And those VIs there that I'm pointing with the arrow are the ones that are in charge of registering for the event. And that synchronization there just says module I'm ready to receive broadcast. If I go to where I press the button to do something, that VI that gets automatically filtered for me is the one that tells the module to do something. And then how it stops is when the end user tries to close the panel, I just go to the exit case, and in the exit case, I stop both modules, and I wait for them to stop. So that's at the top level of the application. If we look at the My Singleton main now, I'm going to look at where I press the do something button. Well, first show you initialization. I create both broadcast and request events, and then I register for the request event. So this is important. Remember we said that request events were many to one? This is where that processing is going to happen. By initializing it and registering for them, the event structure on the top becomes the one that handles things that are happening on the front panel, as well as requests from the exterior, right? And that's the one that starts by the front panel. So on the front panel, I'm just enqueuing a do something. But if I go to the immediate event case after that, I have, remember the application has sent the My Singleton do something. It's because I'm registered for that request event that I get it in this event case. I get my payload, and then I go to the case that says do something. Here is where you would do your something. And then when you're done, you broadcast, I did something. All of those VIs, again, that they get programmatically created for you. So you don't have to code them. And then when it gets the request to stop the module, it's just going to enqueue the exit case, and then from the exit case, it's going to stop the loop on the bottom and stop the loop on the top. And we handle our exit, and we close all our references and stuff. Right, so close. And then, what happens from the API tester? So the API tester, again, it just shows that the code that's calling the Dqmh code can be anything. In this case, it's a while loop with an event structure inside of it. Because all we're doing is testing the API. And same thing, I register for my broadcast events, and I start my module, and then register for that. And my synchronization always does is saying that I'm ready to receive broadcast events. When I press the do something, all I'm doing is call that VI that says My Singleton do something. And these VIs, I can just find them with quick drop because they're already on my project, and they're part of the public API, so that's why I can call them from here. So now remember that My Singleton broadcasted, I did something. Because I registered to listen to the broadcast messages, I get them there. And then finally, there is an option for a synchronous message, and you can also get it scripted for you. Right. And the difference is we have an extra payload there that allows you to say, okay, wait for reply, and instead of being this asynchronous thing where I send a request and then maybe sometime later I get the broadcast, on this one is you wait there until you get the reply back. Questions? No? We're good?
Is there a timeout?
Yes, it has a timeout. One of the outputs of the reply and wait for it has a timeout. So,
How do the references for the events get back to the caller?
the references for the events are wrapped in those two VIs I used at the beginning when you register for events, and it's basically a functional global variable that the module itself, the Dqmh itself, creates both references and keeps them in that functional global variable. We have the Dqmh module own that functional global variable because you ensure that the events are going to be alive while the Dqmh module is still alive. Okay, so quick video for the Dqmh versus NIQMH. I have the Dqmh on the left, the NIQMH on the right, and I'm showing the NIQMH main, and I'm going to overlay on the left how the Dqmh looks. And you're going to see that the Dqmh initialization is very similar. The difference here is that our queue is in, what's that? The NIQMH creates a new queue for each project. So it might have the same icons, but it could be customized. Okay? And then ours, it creates, it might be custom. The Dqmh keeps the QMH in VI library. That means that any Dqmh share the same queue. So the queue type. Now, on the Dqmh, we use events for inter-process communication. NIQmh only uses for the message handling loop to stop the event handling loop, and that causes advanced users think that that's all you can use the user events for. And what else is the difference here? All internal, external messages are the queue here. The event handling loop handles external messages, either sent by the GUI or sent by other VIAs. So this way, yes?
You're not updating. So this connection is down.
The join me is flashing.
What's that?
The gray icon down to the bottom.
It's just telling me you shouldn't be using the Mac.
It wouldn't work at all with Windows with Wi-Fi sharing. So
Yeah, that's true.
the Mac is helping you here.
Pokemon Go solution. T-shirt is no longer available.
So okay, reconnecting. So let me go back.
Oh, good.
So where we were
There we are.
at the a little bit farther. So all events are that's the user events being used for something else. Okay.
Yeah, that's where we dropped down.
Okay, perfect. So the events, both the events get saved as part of the project.
You're out again.
Now, so it says that I'm connected, not reconnecting.
Funny, the YouTube video is working. So.
Yeah, so it means that I do have some internet at some point, right? Isn't it?
Well, you've already got it queued up, so or you streamed it all.
Yeah.
Very buffered.
Come on. I guess I was not meant to do these presentations today.
Hey, we're here.
Yeah, we can still see it. Poor guy's on the phone, but.
All right. Okay.
Fabiola should have a Dqmh CLA example that I can post.
Oh, if you want to pay for it, I'll. Okay. All right. So the next thing was just basically saying because we have the two loops, the event handling loop gets your way when you're troubleshooting. You know where your messages are coming from. If it's coming on the loop on the top, you know that it's either a user event interaction or a user clicking something. I hate the fact that they're called user events. Or is it a custom event that's being fired by another Dqmh module and it's trying to reconnect again? So anyhow, so that's the main thing. So the main differences are the Dqmh module message queue is private, while the NIQmh, the power loops can access other loops queues. So this is one of the pet peeves that I have with the NIQmh. It basically handles the queue references to anyone to use. The Dqmh is extensible via user events, or just adding a new Dqmh, and the NIQmh is moderately extensive. The Dqmh can give you a dynamic number of parallel tasks, while the NIQmh is the static number of parallel tasks. There's, who's familiar with the NIQmh sample project template? The one that's called continuous login. So what do you guys think of it?
It's very complex. But it works.
It gets the work done, right? Yeah. So that's the main thing. One thing that I tell people, if all you want to do is acquire some data, log it to files, and move on, that you should just use that. You don't need to get any more complicated. Some of the challenges that I see is that the parallel loops cannot be loaded at different times. So for example, if there's something wrong with your DAC device, you cannot just restart the process for the DAC device if that loop doesn't handle that. Or if you want to connect to to use the program to analyze the data that you acquired, but at that moment you don't have a DAC, you still have to start the DAC process. And I understand there's a way around them, but just out of the box, that's what it does. If application grows, it can get unruly, and finding where a message was in queue can only be done by text search. So, and Windows. Like I said, it's probably not by day. So, well, that's doing that.
You had a RAM? Maybe LabVIEW won't crash.
If this is Windows, it had blue screen already, so.
Yeah. So this is the VM running in there, isn't it?
Oh.
So let me see if I can start some of the other videos while that's running. So where's my address? I'll let it restart. And okay. So I already showed you this. Let me show you the project. So this is the NIQMH Continuous Measurement and Logging Sample project. And you guys are familiar with this. You said so. So basically what happens on these guys is you have a loop for the acquisition message, a loop for the logging, and a loop for the data display. And this is where the problem I see is that you initialize all your queues, and now you have them in a cluster, and that cluster is the one that share among all the loops. All right? So what happens a couple of months later, and you want to make it 5 simple processes to control a loop, and then add one motion loop just for good feel. You start getting something like that, right? So you start getting a bunch of loops on the bottom, and then your messaging system on the top ends up getting really crazy. And yes, there are ways around it. You can wrap those guys in SOVIs and all that, but if you follow the concept given by the template, you can easily end up that. So what if all control processes are identical? Or what if the number of control processes vary? If we use Dqmh modules, then the acquisition is going to be a singleton and the process control is going to be clonable. And then the way you start multiple of them is just put a for loop for the clonable and you're set. So you have as many modules as you want. Really? Okay. All right. So what happens if I want to reuse? If I drag in the NIQMH, you get a bunch of errors, right? The reason is because remember the queues were unique to each project. So I cannot just put my loop down here and just connect it, because the guy on the queue there is only looking for a user interface reference, where the loop on the motion, so there's only one user interface reference, where the loop on the bottom, the motion loop, was waiting for a motion control and 5 process controls. So reusability, yes, I could reuse it, but I have to go do a lot of stripping out. Reusing a Dqmh module. If you have your library, you just drag the library you want to reuse, put it in the new project, or you copy it and save it with a new name, and then you get your library there. And I'm going to create a new VI. And at any time I get in a bunch of errors, and all the time I never get a broken arrow, right? Everything seems to be working fine. So I can either drag things from my project or use QuickDrop, because they're on my project. So I can do that. And I'm just doing a very simple VI there. So what ends up happening with this simple VI is I start the module, I register for the broadcast for figuring out that the module did init. I have my indicator there. And then I just stop the module at the end. Do all my wiring, my timeout. Okay. And then when you're done with that, if you try to run the VI, it starts. So reusability of just having, and again, it doesn't have to be a Dqmh. It could be if you're doing actor framework, you can have an actor. If you're doing any other type of architecture, the fact that you have something where the basic message mechanism is common to all of your architectures, then that means those modules can be reused. Questions? No? they give you that because they know they're going to crash. But it's really not putting me down where I left. All right. So slash from current slide. So we already have that, and I already showed you the video. User events. Everybody here agrees with me that they're poorly named. They should be called custom or dynamic events. There's several required steps: create, register, fire, handle, destroy. I think the biggest thing is that they're underused. When I teach advanced architectures in LabVIEW courses, and I ask here people, you know how to use user events, and everybody's like, oh, of course. And then I'm like, but I'm not talking about clicking buttons on the front panel. You're not? So then it turns out that they don't really know what they're using. So why do we use them? Broadcast makes it easier to send a message to the world. It doesn't matter if there are listeners or not. This is my favorite thing. An event queue is created for each listener. If there are no listeners, there's no event queue. So what happens if you create a queue, message handler, and you are putting things in the queue and there's nobody dequeuing? Memory leak, right? In the event structure, if there's nobody registering to listen to those devices, to those events, the queue is not created, so there's no memory management there.